So all we're doing today is pretty much the same thing that we did before, other than we're going to end it with either an actual slope value, which we've seen in action, or as an equation of a line. We could see it that way as well. So with a slope and with an equation of a line, which means we, again, do exactly what we did. So this is good review for your test, which is tomorrow. And then we take one extra step, one or two extra steps. And so to get started, I want to do the definition of derivative on this first problem. It is a rational function, which means it's a fraction. And I'm going to use my definition that I've done, so I need to know what f of x plus h is. And even though it looks a little scary when you have that fraction and that x plus h and whatever in there, but it's not. There's not a whole lot of simplifying that you do, and we just have to find a common denominator, and things actually clean up pretty nicely. So my definition of derivative is, the derivative is found by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. Ring a bell after the weekend? We good? Yeah, looks familiar? We did, yeah. And then when we're done, we'll plug 3 into x, yeah. Yeah.
So it's the same thing, but you just
Yep. Yep. In fact, you could even right now plug 3 in for x and work your way through. You'd get the same answer, but I'm just going to work through the way that we did. So this is, I didn't take my limit yet, but I'm going to do the common denominator. So I'll multiply the first fraction by x minus 1, which is 2x minus 2, and the second fraction, which I'm going to assign the minus 2, by x plus h minus 1. And this will all be over the common denominator, which is that kind of ugly thing, but that's okay. We'll take care of that later. And now I'm going to do my simplifying, distributing, bringing stuff through. I still didn't take my limit yet, and even if I tried to take my limit at this point, I'd end up with 0 over 0. So this is 2x minus 2 minus 2x plus 2h, minus 2h plus 2 all over the common denominator. All over h. I don't know again why I put that there. This is getting messy. Sorry about that. If you did this correctly, a lot of things should cancel off. So 2x minus 2x minus 2 plus 2. I'll put my h over 1 and then I'll flip and multiply. And I'll also cross off my h. So as ugly as this is or was, it's going to clean up very nicely, very quickly. And I still didn't take my limit. I'll do that next. But I just have negative 2 over that common denominator. So again, once I distributed it through, I was able to cancel a ton of things off, including the h term that was in that one term that was left, minus 2h was left. So the h gets crossed off of there. And now I'll go ahead and take that limit, plug in h, 0 for h, I mean. And when I do that, I lose the limit, and my first derivative is negative 2 over x minus 1 quantity squared, because the h is gone. I end up with x minus 1 times x minus 1. And so what is different about today? Because so far this has been exactly the same thing that we've been doing. The difference is I want f prime of 3. And when I plug it in and evaluate it, all it tells me is that the slope of my tangent line is -1.
Don't we need to square the 2 at the bottom though?
I do. So it's not 1. It's -2/4, so it's -1/2. Is that better, Jolene? Okay. Yep, that's squared on the bottom, thank you. So -1/2. And again, that's it. I go through the same process of everything, and then I go ahead and plug in the value at the end. Let's see, I'm going to do number 4 on this page. I'm going to skip 2 and 3 because, again, it's not any different. It's just good practice. And in fact, I'm going to pause the video and I'm going to let you guys go through and see if you can do that derivative on problem number 4. And then we'll revisit it and plug our value in. And then, like I said, we're going to take it one step further. We're actually going to write an equation of a line. That'll be how we finish off today. But you'll see that it's not that much more of a challenge. Kind of the same thing. It's just that you're going to have a different looking end result. So give this one a try, see how you do. Number 4, derivative again. I go back in and evaluate it at the location that they were interested in. They wanted to know what the slope of the tangent is when x is 1. And so my slope is 2 times 1 plus 1, or 1 over the square root of 3, or when I rationalize the denominator, the square root of 3 over 3. Okay? Now, I do want to make a comment again because at this point we're using f prime because that's what the definition of derivative is, but you're going to see me use a lot more dy dx when we get into our shortcuts. And when I do, if I would write this properly, if it starts off as y, then I write dy dx when x is 1 equals the square root of 3 over 3. It means the same thing. Dy dx at x equals 1 is the same thing as f prime of 1. They're exactly same meaning. Again, it's just a different notation for it. All right? Are we okay with that? Yep.
We left it as 1 over 3 squared, is that right?
If you left it as 1 over the square root of 3, I wouldn't care too much. Sometimes it'll ask you to simplify or whatever, but. All right, so next step, again, not a big step, but the next step is that we are going to be actually writing the equation of the line, and the equation of the line that they're interested in is slope-intercept form, which you guys have seen many, many times throughout your career in math. And slope-intercept form is y equals mx plus b. Look familiar? So we're going to be finding our slope. That's going to take the place of the m portion of this. And then we're also going to be inputting our x and our y, and that's the thing that's in the point next to the problem. This is the given point. It says at the given point, and that's what this is. This is my x and my y. And then we're going to have to simplify it and get it down into y equals mx plus b. I am going to be doing this using another form of an equation, and the other form of the equation is called point-slope form. And it's called that way because if I know a point and I know the slope, I can plug it in pretty easily and find my equation. And point-slope form looks like this. Y minus y1 equals the slope times x minus x1. And it's actually 100% derived from the slope formula. If you divide the x minus x1 out, you get y minus y1 over x minus x1 equals m, and that's exactly what it is. The only difference is when we're using it here, we actually know a point, and this is the x and the y that I know, okay? So when I plug that in, this is x and this is y. Yes, you will be given that form. I will write it up on the board, so you'll know what it is. It's not like you have to memorize that new form, but you do need to know how to use it. And it really is a matter of just kind of plugging stuff in. We're gonna start the same way. We're gonna do our derivative, and then we're gonna plug those values in to solve. I'm gonna skip 5 here. Again, when you get into a squared, it's more complicated and it's not worth it. We're gonna be able to work through those when we do our shortcuts. I'm not gonna give us a headache now for this. So let's skip 5 and go on to 6. We're gonna start with problem number 6. I need the equation of a line, so I need 2 things. Number 1, I need the slope. And number 2, I need a point. Okay? Here's the point given. Now I need the slope. I forgot to have people put their phones in the caddy, and some people I don't think can help themselves, can they? It's
I
addictive.
was just gonna catch up.
Put it away. Put it away. Okay. The slope here is found by taking f prime of x. Okay? So, again, no different from what I've been doing. I'll find my first derivative. I'll plug x in. I'll get a slope. And then I'm going to put it into the point slope form. So that's my third step. Put in point slope form. And simplify. Okay? So let's do our derivative. F of x is 1 over x plus 2. And f of x plus h is 1 over x plus h plus 2. And so f prime of x is 1 over x plus h plus 2 minus 1 over x plus 2 all over h. Oops, forgot my limit. So I'm going to squeeze that guy in there. Plugged it into the definition of the derivative. And now I'm going to simplify. That'll be x plus 2 minus x minus h minus 2 all over the common denominator. All over h. And again, all I did is when I multiplied this second fraction by x plus h plus 2, I made sure to change all the signs by distributing that negative throughout. And then I am able to do my canceling. Minus x, minus 2, put h over 1, flip it up and multiply, and cancel off my h as well. Don't forget there was a negative in front of that h, so that's why I put a little -1 in front of it. So after I did all my cleanup and all of my canceling and all of my flipping and multiplying and taking away everything that I can, I have the limit as h approaches 0 of -1 over this thing. And then the h goes once I take my limit. That means I'm going to put this 0 in for h. And my final will be -1 over x plus 2 quantity squared. Okay? So now I'm going to do my process. Now I need to find my slope. So step 1, my slope is f prime of 1. Where did the 1 come from?
The x-coordinate.
The x-coordinate, yep. And f prime of 1 is equal to -1 over
1 plus 2, which is 3 squared, or negative 1/9. Are we good? This is M. That's what that means. I found the slope of the tangent line. I found my M. Number 2, I take my point. And step number 3, I plug it into point slope form. Y minus y1 equals the slope times x minus x1.
Most of the time, you can stop here. If it asks for an equation of a line, this is an equation of a line and you're good. The only time you can't stop here is if they say to you, please write it in a specific form. And this particular problem says, write it in slope-intercept form, so that's where my cleanup comes into play. So I am going to get it into y equals mx plus b form. And I just distributed my slope and got y by itself. Yeah, did I do bad? That was me taking my slope and my point xy and plugging it into this. You might have missed it. Did you? No, you were here when we did it into this form.
Oh, you showed
Good? Okay. So I plug in my slope and I plug in my x1, y1. Those are the things that are going to change. The y and the x will be in every equation all the time, just like they would be in a y equals mx plus b form. Okay? Okay, let's do number 7. In fact, I'm going to let you guys find the derivative on number 7. And if you're feeling great, go ahead and do it. We'll compare our answers shortly. Let's start by finding your f prime of x, plugging your value in to find your... Got my derivative again. Then I'm going to use the point that was given, and you'll be given the point. And so this is my x1, y1. Those are what I'm going to be using in this value, or when I'm figuring this out. So I have to start by number 1, finding my slope. So here's my number 1 step. Number 1, f prime of 1 is equal to negative 4 times 1, or negative 4. So that's step 1. Step 2, get the point I need. That is 1, 0. That is my x1, y1. It was given. I didn't even have to work too hard at it. Number 3, put it in point slope form. Y minus y1 equals slope times x minus x1. There's my slope. There's my x1, y1. So this is y minus 0 equals negative 4 times x minus 1, or y equals negative 4x plus 4. And that's how we finish that off. Do we have any questions? Do we need to do any more, or are you guys ready to just give it a practice? Ready to practice? Okay. So we are going to call